All right, today we're going to continue on. We will do 8.2. So now that we've talked about what a confidence interval is, what a confidence level is, we're going to actually now work on constructing a confidence interval for proportions. And we're also going to do, for that will be an 8.2 and 8.3, we will do a confidence interval for a population mean. Okay? All right. So first, 8.2, we'll do the estimating a population proportion. Okay. So really, if you're looking at doing a proportion, you're going to start with p hat, right? Because again, you had a population here and you're going to do a survey or sample. You're going to do a sample, simple random sample here. You're going to get a p hat. You had p here, you had a sigma. Okay, you're going to have a sigma p hat here. Okay. So we're going to do a sample, and when we do that, we're going to say, okay, the p hat, the confidence interval is going to be p hat plus or minus z, the critical value, and the thing that we used before, right? Right, we said this guy here was going to be right? What were some of the restrictions that we had? Can anyone tell me some of the restrictions that we had when we're doing this sample? What are some things that we can or cannot do? What do we have to verify here?
Like the 10% rule?
Okay, the 10% rule, you never will oversample, right? So your sampling n has to be less than or equal to 0.1 of the total population n here, right? And you have a small n here, okay? Just to refresh our memory, okay, the reason for that was, this is when we talked about the binomial distributions, when we said binomial, to go from a binomial to a normal distribution, one of the things was that in a binomial, you are supposed to make sure that each independent sample or whatever you're going to do is independent, right? They have to be the same population, same proportion, right? But when these type of things, you will be surveying or sampling without replacement. But as long as you sample less than 10%, you can still say it's close enough to sampling without replacement, even though you are sampling, with replacement, even though you are sampling without replacement, okay? So that was the 10% rule there, okay? What was the other thing?
The large counts
The
condition.
large counts, great. NP has to be greater than or equal to 10. N1 minus P has to be greater than or equal to 10. This is the large counts. And the large counts allows us to say that even if if the population is normally distributed, if this is a normal distribution here in the population, the sampling will be normal also, obviously, right? If this was not, okay, you can say that as long as it meets the large counts, I can say that the sample will end up being normal, okay? So that's why that's there, okay? And the other thing that is really important is it has to be a random sample, right? It has to be a random sample. 3 things: random sample, less than 10%, large counts, okay? So if you go to page 511 on that green box, it shows you what we're talking about. It shows you this guy here, p hat plus or minus z star, which is our critical value here. And this is going to change as what changes? Well, what does this change? What changes this guy here? It's the confidence level, right? The confidence level. The confidence level changes this z star here, right? Okay. This guy here, this is this guy right here, right? This is the sigma, or the standard deviation of the p hat. Okay. Well, we also call this the standard error. This is also known as the standard error. SE, okay? SE, all right? So flip the page. Page 212. Let's discuss the conditions. The random condition, okay, random, right? It has to be random, right? If it's not random, if it's not random, your data is no good, right? Your data itself is no good, okay? So it has to be random, the large counts. We talked about the large counts. It has to be large counts for it to be so that we can say that the sampling distribution is normal, okay? Then you cannot oversample, and we talked about why that, right? Now, if you go to page 513, there's that standard error thing, the standard error thing, okay, we talked about that. Okay, so again, that green box there, underneath there, it says conditions for constructing a confidence interval. 1, simple random sample. 2, less than 10%. 3, large count. So whenever you are doing this in the test, okay, whenever you are going to construct a confidence interval for a proportion, for a population proportion, you always have to bring these up and say, yes, it's a random sample. Yes, we sampled less than 10%, and the large counts is good. So you have to write these things down. You cannot just not state that and go on and construct the confidence interval, okay? So you have to write these down, okay? It has to be in there, okay? All right, example B's. Mr. Buckley's class wants to construct a confidence interval for P equal the true proportion of red beads in the container, which includes over 3,000 beads. Recall that the class sample of 251 beads had 107 beads and 144 other beads. Check if the conditions for constructing a confidence interval for P are met. Okay, so large N is 3,000, and we have sampled 251, right? 251. So obviously, okay, it's a random sample, so we're good with the random sample. That's the first one, we're good with that. Second one, we are less than 10%. Okay, less than 10%. Okay, and then what else do we have to check? We have to check the large counts here, right? N is 251. And P was what? We had 107 red ones over 251. And that is going to be 107, which is obviously greater than or equal to 10. 107 is greater than or equal to 10. Then we have 251, 1 minus 107 over 251. If I do that, I'm going to get the 144. That also is greater than 10. Okay, so it satisfies the large counts also. Okay, flip the page, and it does the large counts, and we're good there. Okay, all right. Okay, now let's go to page 515. This is talking about calculating the critical values. So calculating the critical values is right here. Okay, so this Z is your Z-score, really. It's your Z-score from a normal distribution, right? So if I wanted to do a confidence level of 90%, okay? If I want to do 90%, what does that mean? That means that if I'm going to do 90% in the middle of the normal distribution, that means that each tail has to be what percent? Right, if I want a confidence interval here, right? That means that if I want this to be 90%, what is this tail going to be right here? Can anybody tell me?
5%.
It's going to be 5%, right? So I need to find the Z-score here that gives me the 5%. And I can look that up by doing what? 2 ways. Give me one. Mackenzie, give me one.
Norm CDF.
Norm CDF, I can do norm CDF. Okay, well, if I do norm, okay, I can't do norm CDF because I'm trying to find this guy and I know this. So what do I do then? It's the inverse norm, right? So I can do the inverse norm, right? Or I can go to the table, right? I can go to the back of the book, do the table of the z the normal distribution z-score table. What do I get? Can anyone tell me what the the z star is then? What's the z-score for a 5% tail? Dead silence. Go to the back of your book. Go to the back of your book. Go to T-1. T-1, and I want 0.05. What number gives me 0.05 there? What gives me 0.05 there in the middle of the table? What is the z-score associated with that?
Negative
Alia.
1 point.
What?
Is it negative 1.64?
Negative 1.64. Actually, negative 1.645, right? Isn't it between 04 and 05? Right?
Yeah.
You see what I'm saying there? Okay, yeah. So good. So this is your critical value here for 90% confidence interval, right? What about 95%? This is going to be 95%. What is my tail is going to be now?
2.5.
2.5, right, good, 2.5. So let's go to stay on that table, and where do I find 0.025? Everybody get this, 1.96? Everybody see that, 1.96? Actually, it's right on the dot, right? 1.96, which kind of makes sense, right? Because we were at 2 standard deviations out. It was supposed to be 95%, right? 68, 95, 99.7%, right? Everybody remember that? So it's going to be 1.9, right? What about 99%? 99%, what is this going to be here? What is the tail going to be? If this is 95, 99.
0.5.
0.5. So where am I going to find 0.5? 0.5 looks like it is in between 0.2575. 2575. Okay. So these are good numbers to keep in mind. Okay. These are good numbers to keep in mind. Okay. Especially these two. You'll use these two much more often than this. Okay. 95% comes up quite often. Okay. Can anybody tell me why 95% will come up quite often? Because 95% means what? The other percent is what? Other is 5%. What is the significance of 5% in statistics?
It's the most common confidence level.
Well, it is, we said, earlier, way back when, we agreed that 5% is where we call statistically significant. Remember that? Okay, so therefore, there are a lot of questions that are going to ask you confidence intervals of 95%, okay? All right, so just keep that in mind, okay? You don't have to memorize these, but I mean, they're nice numbers to have handy, at your hands. All right, flip the page. Read any good books lately? Okay. According to a 2016 Pew Research Center report, 73% of American adults have read a book in the previous 12 months. Wow. That means that 27% of American adults have not read a single book in a year. That's kind of sad, I guess. This estimate was based on a random sample of 1,520 American adults. Assume the conditions for inference are met. So we don't even have to check the conditions here on this one. It already tells us that it's worked, that it's good, okay? A, determine the critical value Z star for a 90% confidence interval for this proportion. Ding, 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 we have a winner, 1.645 right off the bat. Number 2, construct a 90% confidence interval of the proportion of all American adults who read a book. So the actual confidence interval is going to look like what? The equation was P hat was our proportion, right? So our proportion was what? What was our proportion? 0.73, right? 0.73 plus or minus. Okay, and then we're going to get what? 1.645 square root of P 0.73, 1 minus P 0.27 over, what was our sample size? 1520. 1520. Okay, that's it. And if we do that, we're going to get 0.73 plus or minus 0.019. Okay, so this is going to end up being a confidence interval of 0.0711, 0.749. Okay, so that's the confidence interval. And as always, the question that's going to be asked is to interpret the confidence interval. So this is the interval, right? So confidence interval interpretation is we are 90% confident that the interval 0.0711 to 0.749 captures the true proportion of American adults who have read more than one book in the past 12 months. Okay? All right. So again, you have to have that in the back of your head and be able to spit that out whenever they ask that question. Okay? We are 90% confident that this interval here contains the true proportion of American adults who have read more than one book in the past 12 months. Okay? All right, so we'll stop right here for the first part.